Anyway, welcome to DEFN again. I think we spent enough time not doing podcasts. So this time we have just a little bit of technical difficulty, if we can call that. Welcome, Jack, to the episode.
Hey, PJ, nice to meet you.
Hey, nice to meet you. That's the official introduction. But I think let's start with Jack. I mean, okay. So tell us about yourself, Jack. You have I don't know how many minutes left. 25 minutes.
We got 25 minutes.
It's all yours for 25 minutes.
I am an Earthling.
Yeah.
Despite any rumors to the contrast that you may have heard, I assure you that I am an Earthman, like yourselves.
That's exactly what an alien would say, right? to convince us.
He's among us. Yeah, definitely.
So what did you lads want to talk about tonight? Here we go. You've invited me here to this thing. We've tried for months.
Yes, we've been chasing you for months. Well, let's talk about Clojure, or well, maybe even more than Clojure, actually, because I think you did a really interesting talk at was it Strange Loop?
I did a talk at Strange Loop. Whether it's interesting is a question of opinion, of course. But.
Well, I mean, interesting is not an objective quality, right? I mean, it depends on the person. So I'm saying it's very interesting to me, and I'm pretty sure a lot of people found it very interesting. So,
I would say don't talk about that, because you can just go and watch the talk. So
yeah, it's on YouTube. You can find it easily.
Change the subject. Come on, it's boring to talk about the same things all the time.
No, we're not going to talk about the same thing. My question is like, where did you come from?
Oh my God,
to have that much of experience about all the stuff? Because there is the computing you started almost like the punch card level stuff.
Yeah. So what happened there biographically is that when I started, started at university. It was 1985. And punch cards were not the leading edge of technology at the time, as you could imagine, but they were still out there in industry. And so I had to take one Fortran class using punch cards to make sure that were I to end up in industry writing that kind of code on that kind of equipment, I would be able to do it. So in that sense, I'm kind of a member of the last generation of people who were made to do that at university. And I'm happy to report that although I did write some Fortran for money, I did not have to do any punch card work for money. That was all classwork.
Oh, okay. And then the big leap to Clojure from punch card.
Yeah, pretty much directly. Yeah, because I had a time machine, and so I was able to come forward. No. So the early part of my career was spent mostly doing very low-level things in assembly and C. I did some embedded systems things. I was a Unix kernel hacker starting in the mid-'80s. I was mainly like porting BSD to different hardware, working on file systems, blah, 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 that kind of thing. But at the same time, I was very interested in first Lisp and then later other functional programming languages. So, we had Spice Lisp and we had VAX Lisp, which ran on our old VAX machines in the mid-'80s. Of course, there was Scheme, which I encountered originally by way of the classic Intro to Computer Science course, for which SICP is the manual. And then in the sort of latter part of the 80s, there was Miranda, which is kind of Haskell's mother, which the author of Miranda tried to take it in the direction of being a commercial sort of language, and it didn't really take off, and the research community decided they needed something like it to carry on, and that was the birth of Haskell. So I always really liked the pure functional stuff once I encountered it around 87 or so, but I also preferred S-expression syntax and did a lot of Lisping on a wide variety of different environments. And the low-level stuff also brought me into contact with, I've written a bunch of forths. Whenever I encounter a new piece of hardware, I like to write a forth first to explore the hardware and then work from there. And
so forth is the stack-based programming thingy, right? Is it?
Yeah. Some people like to call them concatenative languages. They're an interesting kind of relationship to Lisps, where they sort of put the verb at the end instead of the beginning, and they are based more on function composition rather than function application. But they are both languages that you can start with a very minimal core and build the DSL that you want. They both support a quoting mechanism that gives you something like macros and so on. They're really great languages. I find Forth difficult to write large systems in, but it happens to have the property that it is a good and flexible interactive programming environment that you can fit on arbitrarily tiny, crappy hardware. So it's a nice place to start. When I write a bootloader for some new thing I'm going to develop, I'll often, use CNAssembly to create a Forth and then do everything with Forth for a while until I'm comfortable with how the hardware works and then work my way up from there.
No, so it's basically like the C for the hardware, like the first layer of high level programming language that you
Yeah.
can build quickly, and then okay.
Yeah, the amazing thing about it is how much leverage it gives you, how expressive it is while expressing also extreme machine sympathy. Because the machines we have, they all have a stack discipline on them already. So it maps very squarely to the kind of hardware that we typically deal with. Yeah. Yeah, it's one of my sort of desert island programming languages. I would recommend everybody to learn whether they need it or not so that they can use the perspective that it provides in their other work.
Yeah. But because you started with you mentioned Miranda and then a bit of a Haskell thing, but I know that you have I think strong opinions. Maybe it's my perception that strong opinions about the types and lack of it. So how do you find Clojure versus other stuff in that sense?
Well, so with the, and I do have to mention the talk boringly, a lot of people have an impression from the talk that I tried to deliver in a way that would hint towards how I really felt about it, but I only had so much time. You might notice that I'm speaking in fast forward without the fast forward button through that talk to try to get everything in. So with the transcript of the talk that I host on my own site, I include a bunch of notes, including some things that go into a bit more detail about, that whole question. And it's not that I feel types are useless or harmful. It's that I feel like every other tool available to us, they have their benefits and their costs. And it's best to use them when the benefits outweigh the costs. So for early exploratory programming, I find them actively frustrating. And I think it's very easy to over-tighten the specification of your program too early when you're not really sure what you're building yet. And certain kinds of software, especially the kind of software that, say, Rich Hickey spends most of his time writing, can be actively unpleasant to have a type discipline that prevents you from kind of using the software in an open way. So moving maps around and leaving it open so the next person who comes along doesn't need to change a million call sites in order to enrich some piece of data flow is quite useful. In that kind of software. And then there's other kinds of software where you really do want to tighten it up. And so my more nuanced position on types is that for me, the future of type systems and programming languages is more gradual typing. So if you look at typed Racket, you look at TypeScript, you look at what is sort of kind of, but not quite happening in type Clojure, you see a kind of direction where you can play fast and loose in the early stages and then tighten things up once you know what you're actually doing and only in the places where it makes sense.
Yeah, but I think the idea, I totally understand the idea that, at the initial phase of it, you want to have as much freedom as you want to, as you'd like to have. But then the choice right now is that you have to rewrite in a different language, which is, there is no easy way to switch from, I'm writing completely dynamic shit in Python or Clojure, and then now I know the design more or less, now I can tighten it up, but it's not possible that much, right? With the languages that we have.
Well, there are relatively few languages. This is what TypeScript does. TypeScript adds types as a layer on top of JavaScript. If you find, as I do, JavaScript somewhat unappealing to write, then it's unfortunate that that's the language that you're enriching with the types. And typed Racket is actually very nice and is a great source of ideas in that broader context. There's a whole research community there that's working on this problem and coming up with good ideas.
I think one of the biggest issues that I find in this sense is, there's this idea of tightening things up, which is, I agree with that, of course, it would be nice just to apply the minimum amount of types afterwards. The problem seems to be almost cultural though. It's whether you think in types or not, or whether you think in data. That seems to be a bigger sort of cultural difference that maybe people struggle with, because, I come from like you, I started with C, which was, essentially untyped, you can kind of type def things, etc. but it's fairly wide. What are pointers that can go wrong? Opaque pointers everywhere, so you can definitely play fast and loose with opaque pointers. But the point is that when you think like that, you kind of are focusing on the data that's being passed around eventually. But then you go to Java or C++ and things like this, or Haskell. Obviously, the type systems are more powerful with Scala and Haskell and stuff like that. But you end up thinking in those kind of types first and like the data second. Do you think that matters?
Well, you talk about the culture, and I think there's a real thing there where the people, where the language communities have a culture that points in a certain direction. But I would say also that the culture is following to some extent the disposition of the people. And so I think some people just naturally think type-wise rather than thinking function-wise first. And I think some people naturally think better in, for example, objects than they do in functions and data. And so although I have my preferences, it would always seem the case to me that none of these domains is necessarily the ultimate one, because different people, their brains work different ways, and there should be mechanisms available that match their disposition.
Wait, are we going to nature versus nurture thing here?
No, but isn't it a matter? I mean, you say it's like people. I think the problem you end up with is in a kind of like where if you meet people where they are, which is I think what you're trying to do. That's fair enough. But if you're sort of like designing like the future of computing or whatever, if you're thinking about how should we think, what are the best ways of thinking, like objects and stuff like that don't seem to offer very much. They seem to just offer a kind of odd way of parceling up data. For me anyway, having been through that, before it and through it and out the other side, it doesn't,
Well, there are certainly some type systems that I think are less good than others. So I would say that if a person, and I encounter this very often in the Clojure community, so I'm going to point it, because it'll mostly be Clojurists who hear this, I'm going to point out this particular way of thinking that I think is something of a mistake, is that many people who arrive to the Clojure community's experience with, for instance, object-oriented programming is specifically object orientation as practiced in Java and or C++. And they both have actually very bad object systems, ultimately. And my apologies to the designers of the languages, who are very smart people who worked very hard. But if you compare the experience of programming those languages to programming something like Smalltalk or using the common Lisp object system, you have a completely different world. So I don't think dismissing objects entirely is necessarily as good of an idea as looking at aspects of specific type systems or object-oriented type systems that are a problem. So in the case of Java, for example, the entire culture of Java programming for the first 15 years of the language was based about building ridiculously convoluted patterns to get around the fact that you can't just pass a function, right? So you've got factories because you can't partially apply a function instead. And that's because that type system is really not as expressive as it should be. But if you look at things people get up to in Smalltalk or with Clos, it's actually very good sometimes. There are situations where it makes sense. And just to give you one example of a place where I would tighten types up in Clojure code, for example, in my early career, I would say the code I wrote the most often was like linked lists and hash tables and stuff like that, because I was always going to new hardware where I didn't have a good library. But once that stuff kind of evened out, I found myself rewriting essentially the same sort of linear algebra code over and over again. I have to manipulate these matrices. I have to, and in those cases, we kind of know what that code's going to look like and what it's going to do. And if I can give some type hints that prevent me from passing the wrong shaped thing in the wrong place and can allow the compiler to generate much better code and so on, then it's worth my while,
Because you're mentioning like linear algebra stuff. So mainly are you working, like what is the area of focus that you're applying Clojure and all the other languages that you're using? Is it, it doesn't sound like it's a it's a web programming kind of thing, like CRUD applications.
I don't do much of that. I'll say that for the record. I have done some of that in my professional career to make money, but it's not the most fun that I have, right? So, but what I do find is that there are a tremendous number of things in my life that are easily expressed in the terms of a vector or of a matrix across, maybe you need an adjacency matrix because you're doing some kind of path tracing thing, and it's more efficient than building out a bunch of nodes with pointers or something. It's just even that you need some way to efficiently deal with big boxes of things or whatever, shapes that have numbers in them. But there are also loads of things, simple mathematical things. If you want to do something with a complex number, you're probably going to use a 2-vector to represent it, and you want to have it not mix up the types when you're making calls and so on. And Clojure has some nice ways to do this. Like you can use def method to do some of this stuff, like you would do in Common Lisp and so on. And those are useful. Those are actually object-oriented abstractions. That's not object-oriented. That's just a better kind of object-oriented.
Yeah. But so are you using any libraries? Because for this computing stuff, the stuff that is, I think, Dragon and other folks are building, like all the linear algebra libraries, or are you artisanally coding in Clojure?
So I do have I do have a private wrapper around Blast, LAPACK and Blast that I wrote in 2009 or so and have been carrying around with me. I have been meaning to update the code that depends on that to use Neanderthal or something instead, because I would prefer to push the dependencies out to things that I can share with other people when possible. But then a lot of things are just running on the JVM. If I don't need that much performance, it can be very convenient to just hack it the other way. And in that situation, if you need a really flexible, well-designed API for doing those kinds of things, then Karsten Schmidt's Geom stuff and his mathematics library, that stuff is really good. He's moved on now to mainly working in TypeScript, but the code still runs fine. It's Clojure code. It doesn't rot very fast. So yeah, and it all runs equally well in ClojureScript and Clojure, so you can write this code in a ClC file and use it in both. And yeah, so that's what I would recommend for most people who just need a good flexible API and don't care about the performance. If you need slightly better performance and don't care about ClojureScript, then you can use the FastMath library, which is written by someone whose public name is GenerateMeBlog. Who's a very nice guy, who's a member of the community and does a lot of art stuff. So yeah, I guess you guys are also aware I do a lot of digital art, and a lot of that stuff, of course, is quite mathematical in its underpinnings. And so yeah, I'm doing a lot of things with matrices and so on in that context.
Yeah, but this digital art thing, well, probably it's not related to Clojure, but hey, it's not a Clojure podcast anymore, so fuck it. And we're talking about everything here. So how do you feel about all this stable diffusion and what is it, mid happy face, hugging face thingy, and all these things generating art? And then I know your art is more generative art, like it looks like more mathematical.
Yeah,
in a sense, everything is mathematical, right?
Yeah, it's all. I mean, that stuff's all linear algebra at the bottom as well. Yeah, I have done work since an early stage using neural networks to produce art to experiment with it, but I have never found the practice very satisfying. So for me, there is a kind of flow state that one can get into where there is a connection with the work that's being done, and you steer the work towards the part of the latent space that you want by changing the code, and it's kind of like a painter painting with a brush. I love that feeling. When I type a clever prompt into a model that generates a picture, often the output is very cool looking, but the actual process that I am using to do it is not at all gratifying. So I don't do that stuff because I don't enjoy it very much. I have colleagues who train their own models and do incredible work. There's a woman who goes by the name Neural Bricolage, who is one of the best. There's also Mario Kligerman. I'll shout out to both of them as people who are doing real competent artistic work, not just using it as like a strange art slot machine.
Yeah.
But for me, it's not gratifying, so I don't do it.
But what is your process like then? Because you're using Clojure plus your homegrown libraries, or
yeah, I've got a bunch of my own libraries, some of which use some of Karsten stuff, some of which use some of GenerateMeBlog stuff, some of which uses stuff that is only my own. I have a bunch of things that allow me to live code the art as I'm going. So I'm always running, in Emacs, I'm evaluating code, it's changing the outcomes. And say it's a 3D thing, I can export that and render it either in my own ray tracer that I've written in C off to the side, or if I want some really elaborate material for which I've not coded up support, I might import it into Blender. I have a thing that transpiles my Clojure sketches into a Python dialect that Blender understands, so it emits Blender files that I can then load into Blender and adjust the camera and stuff. Yeah. I mean, it's pretty much what you'd expect.
Oh. But you didn't try this Unity stuff with Clojure yet.
I couldn't get it to work within 1 hour of playing with it, and
Yeah.
at all, and then I stopped. That's basically my policy on those kinds of things. Is I'll give it a second, and if it's too much pain, then I'll just keep using my own stuff. So I haven't done anything with Arcadia yet, but it does. I like the people who made that project, and I wish them the best. And hopefully, at some stage, it'll work for me, and I'll make some things with it.
Yeah. But what do you see like the positive stuff with Clojure doing all this kind of work, and then the pain in the ass stuff in Clojure for you?
In the art context,
Yeah. I mean,
so
art plus other work that you're doing, like a bit of mathematical work as well, everything.
sure. So for me, I told Rich this the first time I met him at Euroclosure one year, is that I think he has done a really fantastic job at curating a set of features that work well together for the kind of programming that I enjoy.
Mm.
So that is, I think, his approach to language design. Rather than coming up with many languages, there'll be sort of one clever idea and then a bunch of junk, bolted onto it, and you like the clever idea, but using the language isn't very fun. But with Clojure, he was very careful. The sort of orthogonal set of things that he chose, all those decisions somehow hang together in a way that makes for a very pleasant experience writing code that then is very maintainable and continues to work for years and years. So I've got some code that I wrote in 2009 that's still happily in production on a VPS out in the cloud doing what it's supposed to do. And I've had to do nothing to that code in the subsequent 14 years. And I like that very much. The only languages I have that are doing better than that, I have some scheme that I wrote 30 plus years ago that still works, but it's a rare quality in the world we live in, where JavaScript libraries explode 7 days out. It's like one of those spy letters that says, will explode after opening when you download the package from NPM. Yeah. So
it's an invisible ink, that one.
Yeah.
But that is the positive part of it, like the
So that's the
stability
positive
of it.
part. For me, the negative bits are when I need to do something lower level. Obviously, a JVM hosted language is not great for that.
Yeah.
And so I might, drop out and write some C. I have a scheme compiler of my own that's a private thing that I've been carrying around for 25 plus years that compiles to very tight code. So I use that for some things. So those situations where I need to get closer to the metal, obviously, Clojure doesn't work for me. It's a hosted language, and I have to be in a situation where the hosted runtime is the right thing.
Yeah. So I was about to ask like whether you use Emacs or some other shit, which is something I usually ask people. And I heard you use Emacs, or is it?
Yeah, I've been using Emacs
I'm
since
hallucinating.
1985. It is my DNA and the DNA of Emacs are now entwined permanently. I will probably never escape.
So it is burnt into your fingers.
And for people who like to use kind of Apple Macintosh sort of computers and want an Emacs that cooperates with that environment a little better, I have a config, a very simple, small config up on GitHub that is less painful to start with if anyone wants to get involved with Emacs.
So what do you see in terms of the future, like future of programming in general?
You've got 3 minutes, Jack, by the way.
All right, I'll try to answer the question,
shit, yeah.
define the entire agenda for the future of programming in the next 3 minutes. For that, I think I would refer to the last 10 minutes or 15 minutes of my talk at Strangeloop to give you a sense of it. But so I like applicative languages in general. I like Clojure in particular, and we're doing a bunch of experiments over at NextJournal to try to improve programming experience using Clojure. One of those is Clark, or for Americans, Clerk, which is firstly computational notebook, but a lot of other things too. You should watch Philippa Markovich's talk on this from a recent Clojure conference, where she gives many excellent examples of the kinds of things you can do with that software even today. And we are rapidly building new bits and pieces that will be kind of like the Iron Man supersuit that any Clojure developer can put on and fly around with superpowers.
So
Some of that
it's basically so it's basically explorative programming. That's where you see the whole or most of the exciting stuff is going to happen.
Well, I think interactive programming is super important, and I think it's an area that we've mostly been ignoring for the last 20 years or so in how we approach designing programming languages and programming environments. I think as you know, I like types and I like using them, but I do feel we've been obsessed with them in academia, and it would be nice to work more on some of these UX, user developer experience kind of ideas. We have less
Mm.
than a minute.
Ooh,
Dim
nice.
dim 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 dim.
A few moments later.
So yeah, so you're talking about the exploratory thing that that you think it's going to be like one of the things that we ignored, and then well, kind of it's on the fringes of the programming, right? And then it became uh, sort of mainstream with Clojure, and not anymore.
Well, I mean,
Um,
as mainstream as you can call Clojure, I suppose. Yeah.
yeah.
You know, it's always been there in various languages. The Smalltalk people, the Lisp people, they have a
Mm,
long tradition of interactive programming. And the Forth people, of course,
mm,
Forth is interactive. It's one of its great strengths.
mm,
And many of the other languages that are not interactive could be.
yeah.
So, for example, with if I'm programming in Haskell, I tend to use the Haskell interpreter off to the side. The problem is
Yeah. Yeah.
that binary crashes quite often. It's
Yeah.
extremely fragile. So I suppose it's not completely correct by construction. But you know, I do what I can, and the same if I'm using OCaml. I also there I will always run the top level utop off to the side because for me, I want to interact with the program as I'm running it. But because the cultures, and this is back to what Ray said earlier, because the cultures of those languages are not as interested in interactive programming, the
Mm,
tools are not as good for it.
mm. But did you well, obviously you did. So I'm imagining what other languages that you use? Like, do you reach out to Clojure as the default one for all the stuff, or you already mentioned a bit of Scheme? Um, any non-Lispy languages that you're interested in or playing with, or
Oh, I mean,
you see some promise?
I've used dozens of languages over the course of my career, and there are
Yeah.
things to like in many of them,
Hmm.
and things to dislike in all of them. You know, that's just the nature of programming languages.
Yeah.
I would say that my default language for most sort of day-to-day programming tasks is Clojure at this stage.
Mm,
It's a nice language. I'm very familiar with the standard library and the surrounding tooling and all those other things that make it easier to get work done.
mm,
But obviously, if I'm doing something lower level, then I'll reach out to another language. I've
yeah.
recently written, just as an example of some other languages, I've recently rewritten some things in Rust and
Hmm.
in Go and
Hmm.
a bit of assembly language. I had to port my Scheme compiler to ARM when I got a new laptop. So that
Yeah.
was a couple of days of fun.
Hmm.
Yeah. So what I reach for depends. Oh yeah, and I use Python for some machine learning things sometimes because it's easier to participate in the ecosystem than to start over from scratch over in my own world. Not
Yeah.
always, but sometimes.
Yeah. Actually, I was about to ask about Python because, as you mentioned, most of the machine learning stuff, I mean, it's kind of like took over, right? Python basically became the de facto language for all the data sciencey sort of stuff. Um, but do you miss anything from there, like all the scikit-learn stuff or all the Prophet and different libraries that Python people put out, mostly PyTorch and everything? And do those things, do you think, oh, those things are not missing in Clojure world for you?
Well, I would. So I'm in the weird position where I know all the stuff from the math side and all
Mm,
the stuff from the machine side. So when I need a thing, I generally just make the thing. But it's
okay.
not practical for most people in that situation. They're either
Yeah.
sort of more data sciencey people where they know the maths, but they're not really implementers, and it would take them forever to build the libraries they would need, or they're implementers, but they are not really strong on the other side, and so they wouldn't really know what to build and so on.
Mm,
From that sense, I don't miss it so much.
mm,
But I will say that because the ecosystem is so large and well developed for things like machine learning, that it is pretty time consuming to do it yourself, to recreate a lot of those things.
mm,
On the other hand, I have found on the Python side that the library ecosystem is so enormously fragile and fragile all the way down to like if you're doing some machine learning thing and you're using an NVIDIA video card and now you're trying to run a library that was written a year, you know, something with a library that was written a year ago on a new piece of hardware, something will have changed in the API and the driver that will require you to refactor code at every layer up the stack where you can't
mm.
even run the code. So the rate of bit rot there is just excruciating.
Yeah.
Whereas in my own stuff, I have code, you know, 15-year-old machine learning code that still does what it's supposed to do because the layers underneath are not quite so quicksandy.
Yeah.
You know.
I think it's the way the dependencies fail in Python is crazy, or not change. the levels of transitive dependencies, and then because I write some Python code, and then like 4 levels deeper, some library changes something, and everything breaks because there is no you know constraint put in one of the things. So this whole package management thing is a shit show. But but I'm curious about your view on next journal versus, because that obviously that's the one that you're working on. But if you see the things like Jupyter Lab and these things, so what is there any difference that you see, or are they trying to solve the same problem like you guys?
So in the case of NextJournal in particular, uh, the the emphasis was on reproducibility, on avoiding exactly the kind of thing I
Mm-hmm.
was just talking about. So that was one, and the other emphasis was on being able to use multiple languages in the notebook in a very transparent way. So with NextJournal, you can go through and have Julia, you know, code cell here and a Python one here and an R one there, and they can all talk to each other through a kind of file system layer that's happening underneath. And for each of them, the code you've written plus all of its dependencies is stored permanently in a content addressed way in a Docker container that can be pulled up later. So the idea there is that if scientists do their work, we want to be able to rerun their analysis later. Otherwise, there's no reproducibility. Even if they did good work, we don't know what happened. We'll leave aside the problems of just getting scientists to post their data publicly. But assuming that they have posted their data in their code, a lot of time the code, for Python reasons that we just discussed, is useless
Yeah.
within 6 to 12 months because the ecosystem has moved on. So
Yeah.
I was not involved in making the decision to build that product. That's really Martin's baby, and his thing was to try to make science work better by making better tools for scientists to use.
Mm.
So far, I think it's mainly turned out that the incentive structure for the actual scientists has not pushed them in the direction of caring about reproducibility over the long haul, which is a cultural problem rather than a
Yeah.
technological one, and thus much harder to solve.
Yeah.
What do you use to pass the data around? Because you hand wave, you said some file system type stuff, but I guess you need something to serialize and deserialize, or
Yeah, so the bad news is I don't have like a we just use Apache Arrow kind of story that unifies
No.
everything in a nice, tidy way. Instead, you have to pay attention to what file formats you're using between the different things and so on.
yeah.
The code cells run top to bottom, and there's a kind of file system projected underneath that's shared among the different runtimes that are running the different languages. And so, if you're emitting some format that you have a library for in your various languages, then you can read them back and forth between the languages.
Okay.
In an ideal world, we would probably have a data flow architecture that just handles those things directly without a file system abstraction. But unfortunately, for most of these languages, it would mean fairly radically changing the way the code works for the language and thus breaking compatibility with what I think of as copy paste compatibility.
Yeah, yeah,
Mhm.
yeah.
Yeah.
Yeah. So you end up with JSON or Avro or Protobuf or something.
Yeah, yeah. We would end up with something like that, and then runtimes that would look more like observable, but for the various languages. Like that would be the nicest way to do it. But again,
Mm.
it would break ecosystem things that people need because the whole reason they're using these languages is because of the meta X do what I want aspect of the libraries.
Hmm.
Yeah.
Mhm.
But the if I understand correctly, because you can use multiple languages in the same flow, passing data between them must be pretty complicated, right?
Well, it's not too bad. Everybody can read CSV, for example, and there are
Oh
a
yeah.
bunch of other
Okay.
formats like this, some of which
Yeah.
are,
Yeah.
are packed binary formats that everybody
Yeah.
has a library for.
Yeah.
So if you have to do it, you can do it this way. And there's some other
Mm.
cleverness, but I'm not sure how much of it is shipped at the moment.
Yeah. Yeah. Yeah.
Yeah, but I think the thing about notebooks in general, which I like, is this sort of literary programming aspect of it. Where you can communicate like the growth of a program. Because I think that's one of the problems with programming, isn't it? Is you end up just looking at the finished thing, and it's it's sort of it's difficult to communicate what choices you made as you went along in that environment. That's the nice thing about a kind of literary style where you can, yeah, like I say, you can kind of show the thoughts and the options and the choices that you made. Um, and then people can review it in that sense, which I prefer than this bullshit we have with GitHub at the moment.
Yeah, I would agree completely that literary programming is a very nice way to kind of explain what's going on. And I would say that we don't generally, as a culture in programming, we don't spend enough time thinking about explaining the code to people who didn't write it. And that person who, or maybe didn't write it isn't enough. Like that stranger who's looking at the code, scratching his head 6 months from now might be you. So you really want to make sure that you wrote down what you were thinking right now, so that future person, that future version of you, isn't just cursing your name.
Yeah, I get very frustrated with this idea of just read the code. It's like, well, yeah, okay, can do that, but it's not very efficient.
And I would extend that even to code review. Like other than very trivial things,
Yeah.
I don't believe in asynchronous code review. I want to actually talk to someone and have them explain to me what they were trying
Yes.
to accomplish and what trade-offs they made. I don't want to just look at the code and make sure there are no typos. The compiler can do that. It's,
Yeah, exactly. Yeah, it's very. I mean, that's why I like pair programming, mob programming, things like that. And funny enough, I was talking to a colleague of mine the other day about, and he was saying that they do exactly this where he used to work, where they would not do a PR in the traditional sense. They do a kind of walkthrough PR, and we're going to start doing that as well because well, we've mostly been pairing, which is great because then you don't have to explain so much. But as we do less and less of that, then yeah, these walkthroughs sound ideal.
yeah, that's definitely.
I haven't got much experience of it, to be honest. I don't know about you guys.
Yeah, so we pair a lot, at least in my team.
No, the other part though.
The walkthrough PR is not something we've done. Unfortunately, we're mandated to have PRs and approvals on them from auditors. But I kind of agree that they suck in the sense that if either the PR is trivial and then I can read it in 5 minutes and like sign it off and it's fine, but then it probably didn't need to review, or the PR is non-trivial and it's essentially going to take me more time than it took the person who wrote it to review it. And generally speaking, that doesn't happen. So you sort of get a rubber stamp. But yeah, for audit reasons, we're sort of forced into this process at the moment. But yeah, it's
You guys are using PRs. I mean, you're supposed to send a patch via email and attach it to Jira. I keep forgetting.
yeah,
official
it can
approved
always
way
be
of,
worse.
right,
That's
sharing code.
true.
So I would say also that not doing the walkthroughs, the very thing that you're talking about how it gets to the culture of LGTM, right? Looks good to me because nobody has time to actually do the thing.
Yeah.
And when I look at that combined with the style of management, and this is from a particularly degraded form of Agile that works by making a zillion tiny little tickets, and then one person takes a unit of work off and in isolation of the rest of the system works out how to kind of half-ass get the feature or the bug fix done, and then somebody else rubber stamps it and it goes in, and then you look up in 6 or 12 months and you realize that you have an unlimited quantity of architectural debt because no one has been zooming out and discussing the big picture as they've been going. And that's one of the things that I think is better when you do these walkthrough PRs and you talk about the motivation and you talk about the architectural consequences of the decisions you're making. How good is this API going to be? How much will it distort the rest of the system to have this API? This is the grown-up stuff that you have to be able to do ultimately.
Do you think there is a chance, or based on the literature or the knowledge that you have and experience, so is there any technical solution to this problem, or do you think it's purely people's problem? So you just need to slap on their on their fingers and then say, no, we're going to do this way.
Well, I don't recommend finger slapping necessarily.
We're going to edit that part out, and then we say, Jack said. No, what I mean is that organizational change is a different thing than if the technology for like type systems like Haskell forcing you into a specific type of thinking. Do you think the tools can help here, or the technology can help here, or a language can help here?
Well, I think the tools can help in the sense that they can reduce the friction to doing what is the right thing, in terms of they can help the people to work together better.
Yeah.
But I think we actually, and this is partly because of the most common disposition we have as people who fall into this trade, are people who work very well alone, most of us. And so the tools are often designed with this idea that everyone is an island and they're sending notes in little message in a bottle style off to the other islands, when we should be doing more work together, and the tools that we use should be facilitating and encouraging that kind of togetherness. And then good management, which is actually very rare and very difficult, and which helps people to establish trust within teams to be able to do their best work. Because if you don't feel like you can say, I'm not sure if that's a good idea because this is the guy who blows up every time you criticize anything he does or whatever, then those things also will gradually destroy the quality of the work that comes out. The human factors are intensely intertwined with the technical factors, and if you try to work on one in isolation of the other, you will have problems.
Yeah. I mean, if there is a great tool and then that's going to solve all the problems and then everybody will adopt it and then we'll all be using Emacs anyway. So
But I'm not sure if it is a tooling problem.
Your mic's very quiet, by the way.
I'll
Martin.
get a bit closer.
While you're doing that, let me interrupt.
I've had it.
No, go on.
No, it was. I was just thinking. I don't think this is a tooling problem. I think we fall into the trap of thinking that stuff can be fixed with tooling, but other engineering disciplines have this as well. Like in electrical engineering, only for electrical engineers, like you can't solve this with another tool, right? Like, I mean, you're designing a CPU or a board, like some documentation on the side is going to need to happen. And
yeah, but Wouter, you're an idiot, mate. You're not thinking about software. Software can fix everything. Remember that.
Yeah, I know.
This is the. I'm joking, of course. You're definitely not an idiot, but the thing is, this is the problem with the Silicon Valley mindset. Is that we just need tools and we just need this idea, and this idea that it's solvable via tooling is in itself a kind of illusion that they're very happy to sell.
Yeah, I think certainly looking for some kind of absolute solution from a technical tool would be ridiculous. But I do think that we tend to follow the easy path of the tools that are presented to us. So in the GitHub PR situation, the easiest way to do that is you shoot the PR off and somebody else, their easiest path is to type LGTM and then it's done. So you need both social infrastructure, but also tooling infrastructure that encourages the good stuff.
And so what we try to do is we have like a hierarchy of documentation. So there's stuff that goes into code comments, which is very much like this implementation is kind of iffy. Let's write down why it is iffy so I understand next week. Then we've got this thing called ADRs, architectural decision records. They're essentially markdown files. We ship them in the same repo. And they're the zoom out stuff you talked about, where if you need to change an internal API or something around how the code is structured, module wise and communicating, that will be captured there, where we'll try to sort of address what problem is this solving, how is it evolving the internal APIs, etc. And it's again mainly for us to capture the discussions we had with the team. And then we have what we call like zips, but they're, our other companies call them RFCs or whatever, which are like the really high level architecture of like, okay, we have this system, this is its purpose, and this is its super high level, clouds and arrows diagram, and which we tend to write before we even begin coding a system. But
I think it's mostly discipline, right? Like
I think but it requires a lot of discipline to capture all of it and capture all of it greatly. And I think their tooling can help, but I haven't really seen anything that's better or saner for this type of stuff.
I think it comes back to Jack's point, though, that a lot of it is management and leadership and having people that understand the ineffable nature of this problem.
Integration rows, probably.
Speaking to the ADRs, what I find so important about documents of that kind is that when you look at you bisect your repo and you look over, you can see very quickly what was done. But without the ADRs, you don't know why it was done. And that's the part that if someone comes along later and they see something in the code that looks a bit fishy, they may start trying to refactor that code and then spend a couple of weeks to find out that they're breaking something at a distance because there's some reason, there's some dependency, there was a why involved with that decision. And then so, that's, I think, super important that you take the time to write those documents that clarify those things. And it's also, I think, speaks very well of your team that you do it in the repo, because that's where those things belong. And a lot of teams will split those things off and put them in Google Docs or somewhere far away from the code. And the farther away they are, the less likely it is anyone will look at them. And that's one of the kinds of things I mean when I talk about tooling decisions. Is your tooling decision to make somebody use a crappy web app that's far away from their editor? Or is your tooling decision to use something that feels very native to their workflow that will encourage them to touch those things more often?
Hmm.
Yeah. Do you have to log in to understand the code?
Yeah.
It's a big problem.
Nice.
Even one of the main reasons we chose to commit them to the repo is actually
Yeah,
because
you're incredibly quiet, Wouter. For a sound man, come on, mate, sort it out.
I mean, it's like why we chose the repo also is because it does happen to help with Git bisect. Like it may not happen at like the same Git commit, but like the ADR will have been committed like either 2 commits earlier or 4 commits later. Like it ends up at roughly the same time period as when a particular code change has happened. It's not entirely perfect, but at least for me, I find that it helps grok things. Like you only have to roll time back or forward just a little bit to find the why.
Yeah, now imagine that you had a tool for version control that allowed you to add annotations to the code and to that particular version of the code, and then you can scroll back and forth through it and see the things popping up and disappearing as it goes to get kind of a transcript of the decision making that went in. Right. So, I mean, this is what I mean by there can be better and worse ways of facilitating the kinds of things that you're talking about.
Yeah, definitely.
Cool.
Yeah.
So,
and I think the whole idea of like having like language sensitive tooling as well is super important. Because there are certain trivial changes to types and to data and to functions or whatever, and there are more strategic changes, and a tool could potentially find them.
nice. So, I think we're almost like out of time, probably, as promised.
Let's be respectful.
After hopping through like 17 different services and then going back to this one, Jack, just to wrap it up, like what is next for you? Like what is something that you're looking forward to in general, in not just work, but in computing and anything that you're super excited about, or from all the way from the 80s on, we are on almost like 30 years, and what is the next 30 years?
Well, 30 years is a long time, but what I would say I'm excited about right now from us and from the wider Clojure community is, well, there's a project called Tracy, which is a tracing debugger for Clojure that we're building as a kind of Clerk add-on, and I think that's going to be really great. And we've built this sort of CI hosting thing for Clerk notebooks called Garden that I think is very good, but which will grow into something much more ambitious that I'm not ready to talk about very much now, but I think could be used by many, many Clojure programmers in the future. I'm pretty excited about Emmy, which is a computer algebra system by Sam Ritchie that you will see at the Conj this year. There's also Borkdude's work. I mean, all of it is really, really great. But in particular, what he's working on now with Cherry and Squint, which are like alternative ClojureScript compilers, I think could really change the game in terms of using Clojure on the front end. And I think there's a lot of wonderful work being done in open source libraries from people like Matosin and Juxt. Now, in the wider world, I would say that the uptick in interest in Datalog is really great to see. I've been using Datalog-like databases and, in fact, building them since probably, 25 years now, and it's fantastic to see that Datomic has finally gotten people to wake up to how good that model is. I'm enjoying seeing some backlash against React on the front end. I think for many things, it is sort of a performance sink and quite complicated. So hopefully we'll see more alternatives and move to things like HDMX. Optimistically, if WASM goes in the right direction, I think we should see a flowering of interesting things there, but it'll have to get garbage collection and access to the DOM to be everything that it could be. Again, optimistically, I really like Nix as a package management strategy. It would be fantastic if it were to become easy enough to use that more people would, in fact, use it. And then very optimistically, I'm interested in seeing paid end-user storage as a utility so that more apps can actually be things that people own that store their data in a place they pay for, and we can move away from the kind of surveillance capitalism model that has taken over much of the internet.
Nice. Hey, Thanks a lot.
Cool.
Thanks for your patience and all the shitty technical things. But it's super exciting to finally talk to you. And I think hopefully we'll bump into each other at some point, maybe in somewhere in Europe, because I tend not to go to US.
Yes, I mostly try to avoid it myself. It's far. It's far from where I
Yes.
live.
That's the main reason for me as well. Yes, wink, wink.
But it is a pleasure to meet you, lads, and
Yeah.
I'll see you on the Clojurian Slack. And,
Yes.
Yeah. We'll see you on the conference circuit, no doubt, one of these days.
all right, take care.
Nice. Yeah. See ya.
Have a nice day.
Cheers, Jack.
Thank you for listening to this episode of DefAn. And the awesome vegetarian music or the track is Melon Hamburger by Pizzeri. And the show's audio is mixed by Wouter Dullert. I'm pretty sure I butchered his name. Maybe you should insert your own name here, Dullert. Wouter. If you'd like to support us, please do check out our Patreon page. And you can show your appreciation to all the hard work or the lack of hard work that we're doing. And you can also catch up with either Ray, with me, for some unexplainable reason. You want to interact with us, then do check us out on Slack, Clojurian Slack or Clojureverse, or on Zulip, or just at us at DefAn Podcast on Twitter. Enjoy your day and see you in the next episode.